So let's go ahead and look at how we can do this hypothesis test where we're testing a claim about the means of two populations, two independent populations, using raw data. So the question says, listed in the accompanying table, that means this table right here, are weights in kilograms of randomly selected U.S. Army male personnel measured in 1988. And this is just telling us where those measurements came from. And there's also different weights in kilograms of randomly selected U.S. Army male personnel measured in 2012 from this data set. Assume that the two samples are independent simple random samples selected from normally distributed populations. Do not assume that the population standard deviations are equal. Complete parts A and B. So if we click on this data right here, we can see that we have raw data. So these are just the raw data measurements from two groups, one in 2012 and one in 1988. And we can see we don't even have the same number of data values at each set, right? This one clearly has more. Nevertheless, we have raw data here. They haven't summarized it for us already by giving us the mean or the standard deviation, etc. It's just the original raw data. So what we're going to do in part A is use a 0.05 significance level to test the claim that the mean weight of the 1988 population is less than the mean weight of the 2012 population. What are the null and alternative hypotheses? Assume that population 1 consists of the 1988 weights and the population 2 consists of the 2012 weights. Okay, so we need to figure out what the claim is. So they said right here, test the claim that the mean weight of the 1988 population is less than the mean weight of the 2012 population. And they told us right here, population 1 is the 1988 group and population 2 is the 2012 group. So if we're saying that the 1988 group is less than the 2012 group, and 1988 is population 1 and 2012 is population 2, then our claim is that mu1, the mean from group 1, 1988, is less than mu2, the population from 2012. Since that statement has an inequality in it, not an equal sign, it has a less than inequality in it, that means that that statement is going to go into our alternative hypothesis, the H1. So H1 should be mu1 is less than mu2. Remember, the null hypothesis always has an equal sign in it. So what we should have here is a null hypothesis H0 where mu1 is equal to mu2, and an alternative hypothesis where mu1 is less than mu2. And that alternative hypothesis in this case would be our claim. So that's going to be in letter A. Now that we have that, we need to find the test statistic. So we can go ahead and find that using Statcrunch. To do it, let's go ahead and open the data in Statcrunch first. We can open the data here by clicking on this blue icon, and then to open it in Statcrunch, we're going to click on this little blue box and decide to open in Statcrunch. Okay, so you can see that we have the 1988 numbers in the second column and the 2012 numbers in the first column. All of the hypothesis tests we do are going to be under the stat key, and for this one we're going to select t-stats. Remember, we use t-stats if we're doing a test about a mean and where we only know the standard deviation from a sample, not from the whole population. They did not tell us the standard deviation from the whole population in this question. Indeed, they only gave us the sample. They didn't actually give us the standard deviation. They just gave us the sample, and we're expected to find it, or rather Statcrunch is going to find it for us. The important part though is that it's from a sample, and that's what tells us we use the t-stats. For this one we're going to choose two sample because we had two independent samples here. If these samples were dependent on each other or somehow paired, we would choose paired, but that's not what we had. We had two independent samples. It said that clearly in the question. And we're going to choose with data because we were given the original raw data here, not summary information, the original data. So all we need to do now is tell Statcrunch where this information is. So sample 1 was supposed to be the 1988 group, so we're going to choose 1988. Sample 2 was supposed to be the 2012 group, and then we're going to come down we are going to leave this box unchecked because they told us that we are not supposed to assume that the population standard deviations are the same. If for some reason they told us that they were assumed to be the same, we would check this box. When in doubt, leave this box unchecked. We're going to perform a hypothesis test. Remember, the statement here in our hypothesis was that, in the null hypothesis, is that mu1 is equal to mu2. So Statcrunch expresses it a little bit differently. So if mu1 is equal to mu2, that's the same thing as saying that if I subtract mu2 from mu1, I should get 0, right? If two numbers are the same, then if I subtract one from the other, I should get 0. 4 minus 4 is 0, for example. So this number is going to stay 0 right here, and I do need to change the direction of the statement of the inequality in the alternative hypothesis. Remember, ours was a less than, so we're going to change this to less than. That's it. Now we're going to click compute. And this number right here under T-stats, that is our test statistic. So we're going to go ahead and copy that and paste it into our answer field over here in Statcrunch. This said to round to 2 decimal places, so after the decimal point, we're going to go 1, 2 places to the right, and then we look one further digit beyond that and we see a 9. 9 means to round up, so we're going to change that 7 to an 8. Next, we needed the p-value. The p-value was also provided in Statcrunch right next to the value we were just on. See, here's the p-value. So we're going to copy that p-value and paste it over into Statcrunch. This says to round to 3 decimal places. So after the decimal point, we go 1, 2, 3, which lands us on that 5. We look one digit after the 5 and see an 8, and 8 means we round up, so we're going to change that 5 to a 6. So now we need to decide what our conclusion is going to be. Remember, the way we decide this is by comparing the p-value to the significance level. The p-value here is 0.076, right? 0.076. And the significance level was 0.05. So the way you decide is if the p-value is less than the significance level, then you are going to reject the null hypothesis, reject H0. If the p-value is more than the significance level, then you are going to fail to reject the null hypothesis, fail to reject H0. So in this case, 0.076 is actually more than 0.05. So here we would decide to fail to reject the null hypothesis. We do not have enough evidence to reject the statement in the null hypothesis. So already we know that letter A and letter C are not going to be the answers because those both say to reject the null hypothesis, and we just said we should not do that. So it's either going to be B or D. So now we need to figure out what that actually means in practical terms. What does that mean about the actual claim? Well, if I fail to reject the null hypothesis, then I'm basically saying this statement here in the null hypothesis, it's okay. I have no reason to think that's not true. I have no reason to I don't have enough evidence to say it's not true. So what I like to do is just put a circle around it to indicate, okay, good enough. We'll accept that that statement might be true. Well, if I'm saying that statement might be true, then I have not shown support for my other statement. So I need to cross off or somehow indicate visually to myself that I do not like this statement in the alternative hypothesis. I don't think that's true. I didn't find any evidence to support that. My evidence is supporting the first statement. Well, the null hypothesis in this case was my claim. So by crossing it off here, I'm indicating visually to myself that I have not supported that claim. So, coming back down here to the answers, we would choose letter B. Fail to reject the null hypothesis. There is not sufficient evidence to support the claim that the mean weight of the 1988 population is less than the mean weight of the 2012 population. Now we need to construct a confidence interval that's appropriate for this hypothesis test. So we can go back to Statcrunch and do that. If you just click on options from where you were, you can edit what you were doing, and all we're going to do is go down and change this hypothesis test to this one, which is confidence interval. And what we need to do now is figure out, well, what is the confidence level going to be? So this is how you decide that. It's based on what kind of hypothesis test you started with in the first place. If you started with a two-tailed hypothesis test, then the way you're going to figure out the confidence interval is just by taking the complement of the significance level. Remember, a complement in this case just means we're going to take the number and subtract it from 1. So if the significance level was 0.05, as it was in this question, and we had a two-tailed test, then we're just going to take the 0.05, subtract it from 1, and that would be our confidence level here. That's because a confidence interval is essentially two-tailed. I have a middle section where my confidence area lies, and then I have a tail on the right and the left, which are sort of the not confident areas, if you will. If we have a one-tailed test, then what we need to do is actually adjust that number to sort of turn it into a two-tailed test, or at least to make the picture look two-tailed. So if we start with a one-tailed test, that means that the area in the tail that we're talking about is only on one side. In our case, since we had a left-tailed test, so we know this is a left-tailed test because the direction of this inequality in the alternative hypothesis is a less than symbol, which kind of looks like an arrow pointing to the left. So that's how you can know if it's a left-tailed or a right-tailed test. This is a left-tailed test, which means we would have just had a little area on the left, and in that shaded region would be the value of our significance, the 0.05. But to make a confidence interval, I really need that to be a two-tailed picture. So I need to kind of mirror that area that we had on the left and also have it over on the right. So that means I'd have 0.05 on the left and now another 0.05 on the right, making 0.10 total if I add those together. So the way you can figure out the confidence level if you have a one-tailed test is first double the significance level. Take the significance and multiply it by 2, converting that one-tailed test into essentially a two-tailed test in a sense. And then with that new number, subtract it from 1. So in this case, we had a one-tailed test and the significance level was 0.05. So to figure out the confidence level, we're going to take the 0.05 and multiply it by 2. That gives us 0.10, and then we subtract that number from 1, giving us 0.90. That's it. So now we click compute, and we get the lower limit and the upper limit of our confidence level right here. So I'm going to go ahead and copy the lower limit and come back over here and paste it. This says to round to 1 decimal place, so we're going to go one place after the decimal point to the 8. The 1 after it means that we round down, leaving the 8 as an 8. And the upper limit, we copy and paste, same thing. 1 digit afterwards is a 9, and then the digit after that is a 2, which means you round down, leaving the 9 as a 9.